Hello, welcome to this lesson. In the previous lesson, we discussed how we can write an algorithm using natural language using pseudocode. So now in this lesson, you are going to discuss how we can write an algorithm using flowchart. First, let's get to understand what is a flowchart. A flowchart is a diagrammatic or a symbolic representation of step-by-step solution to a given problem. So as we defined an algorithm, so we saw that is a step-by-step to solve a specific problem. So the same applies to flowchart. Also, the flowchart is a step-by-step of solving a specific problem, but this is represented in a diagram or in a symbolic representation. Flowcharts use standard symbols that help programmers visualize input, processing, and output operations to be performed by a computer program. Unlike natural languages and pseudocode, use of standardized symbols makes the chart easier to interpret, hence more universally acceptable. So with the flowchart, the program or the pseudocode or the step-by-step instructions are more clear compared to the pseudocode or the natural language. So this table shows symbols that are used to create a flowchart. So number one, we have a terminator. So the terminator here, this terminator is used to represent the beginning and the end of the program with the keywords begin, end, or you can even use start or stop. So we call it a terminator, and it is in terms of a no. It's the shape is sometimes we use an oval, or we can use this type of shape. Another symbol is this rectangle. A rectangle here is represent a process. So the process is an instruction that is to be carried out by the program. So the process is for example, you are adding two numbers, you are calculating area. So we call that a process. Another symbol is an arrow. The arrow indicates the flow of the algorithm pathways. So it shows how the instructions flow each other from the beginning to the end by showing how the instructions flow following each other. We have this shape again for decision. So the decision is used to split the flowchart sequence into multiple paths in order to represent selection and repetition. So the decision or this shape, we use it for making a decision. So it is used to check if the condition is true or false. Whenever you have to check whether an instruction is verified to true or to false, so this shape or this symbol is used. Another symbol is this type of shape, which is parallelogram, I think. So this represent input and output, which represent the data entry by the user or the data output or display of data by the program. We have another shape which is represent subprogram, which references another program within the program. So a program can have a subprogram. So when you have a subprogram within another program, you write that subprogram in that kind of symbol. So we have the connector. The connector here represent the with a circle. So it is used to connect sections of the flowchart so that the diagram can maintain a smooth linear flow. For example, you are writing a long flowchart that cannot fit on a single page. So when you go to the second page, how will you know where you ended from? So the connector or the circle will be used to connect the first part on the first page to the second part, which is on the second part. So basically those are the main symbols we use to represent or to write flowchart programs. For example, here we have an example that depicts a flowchart that takes a radius as an input to calculate and display area of a circle. So this is the diagram. So here, as we saw, this is the start of the algorithm. Then, as we saw, this symbol represents the input or the output. So this is the input. It's either input, also this symbol is used as the output. Then here we have this rectangle represent a process. So the process here will be what? Will be to assign the value of pi to the pi and to calculate the area by taking area pi times radius square power 2. So which means it's radius times radius. So this is a process of calculating what? Of calculating the area. Again, here we have the same symbol for the output. So the symbol is doing what? It's just to display the area. So at this point, we are going to display the value which is stored in this variable called area. So simply mean that this is the output, this is the process, and this is the input of the radius. Then when you are done with your algorithm, so you stop or you end you show where the flowchart ends from. So by explanation, here we have some explanation. The first symbol indicates start and end of the flowchart. Then the next line, which is a parallelogram, second symbol indicates the algorithm takes radius as the input. Then you have the rectangle, which indicates that the pi is assigned a constant of 3.142. and the area is calculated as pi times radius times radius. The fourth symbol or the fourth line is the box which displays the area, while the last symbol is the exit or the end of our flowchart. So by the flowcharts are general. The following are general rules that may be followed when expressing an algorithm using a flowchart. Number one, you have to be sure to use the right symbol for the right purpose. For example, it is wrong to use a terminal or symbol for the input. In that case, you will be confusing the programmer. All the symbols of flowchart should be connected using arrow or flow lines and not the plain lines. So for each symbol has to be connected with another using an arrow. The direction of flow of an arrow should be from the top to the bottom or sides depending on the page layout. So which means you have the flowchart uses a top-down system. Then the start and end of the flowchart must be indicated with a start or stop terminal symbols. Flowchart should have only one entry point at the top and one exit point at the bottom or at the side, again depending on the paper layout. So the decision symbols should have only 2 exit points for either true or false on the side or the bottom or and one side. So which means for the decision the decision only takes 2 values, either true or false, which can be either in one side and in the bottom, or another side and bottom. So we'll see how to use that symbol when we'll be writing such programs. So if a flowchart does not fit one page or a column, you have to use a connector to indicate breaks in the flowchart. So those are the general rules you have to follow when you are writing a program or an algorithm using a flowchart. So advantages of using flowcharts. The flowcharts are better ways of communicating the system logic. With flowchart, problem can be analyzed in more effective way. Graphical representation of design serves as a good program documentation, and flowchart makes it easier to debug and maintain a program. So basically, this is the summary of about flowchart. So we'll be writing algorithm using either pseudocode or the flowchart as we'll progress. So now here we have 3 questions. We have written these questions or this algorithm using pseudocode. Now it's time to turn them into the flowchart programs. So may you have any question? So feel free to send me an email or send me a text message on WhatsApp. So in the next lesson, we will discuss the use of variables in algorithm. Thank you.